Okay. So once you obtain your K, which is 1/6, you have to rewrite the table. Okay, so we have, you just replace K in the table. So here we'll be having 1/6. Okay, this is 2 times K, so it will be 2 times 1/6, which is 2/6. Then we also have 3 times K, so that will be 3 times 1/6, which is what? 3/6. Okay, and then 0 for this. So this will give us the probability distribution of the random variable. Okay, that's fine. So let's try an example for me. So let me make f of x equals to let's make it 2k into bracket x plus 1 for x equals to 1, maybe 0, 0 and 1, and then we have k into bracket what, 2 times 2x for x equals to 2 and what, and 3. Okay, so find k for me and write the probability distribution. So find k. So do that for me. Do that for me. If anybody is done, you can raise your hand. Maybe I'll allow you to share your screen so that you can also present your solution. Okay. Yeah, is anyone done? James, are you done?
I'm done.
Okay, Ojo. So,
Yes.
Ojo, are you with a computer or a phone?
I'm on the phone.
Oh, okay.
I'm
So
with the phone.
you can present it to us. I want
Yes.
you to share your screen. Okay, so then speak to it and then let me write over here. Okay, so give me your table.
Okay. The table, we have the X row and the P of X row.
Okay,
Okay. So in the X row, we have 0, 1, 2, 3.
okay,
So to get for 0, we have to put 0 in that X. So that will be X plus 1. So X plus 1, X plus 0, sorry, you replace that X with 0. So that will be 0 plus 1. That's 1. Then 2k times 1 is equal to 2k. So the first, that under that 0 column is 2k.
2K. Okay,
Okay.
okay,
So in the one column is 4k.
will be 4K.
Yes.
Okay, yeah,
And 2 is 4k.
2 will be 4K.
And 3 will be 6k. 3 is 6k.
Then we have 6K. Okay,
Okay.
what
Now
is
we have to find it. Then we add everything together. It must be equals to 1. So that will be 2k plus 4k plus 4k plus 6k is equal to 1.
4K plus 4K plus 6K is equal to 1.
So
Okay,
that will be 16k is equal to 1. So we'll make k the subject of formula equals to 1.
K is equal to
So k is equal to 1 over 16.
1 over 16. Brilliant. So then you replace it in the table and then you get
In the
your
table.
probability distribution. That is fantastic.
Probably.
Okay. Thank you, Ojo.
You're welcome, sir.
Good.
This tree.
Yeah, very well. Class, I hope it's clear to everyone. Good.
Yes, sir. Yes, sir.
Very well. Okay. So with this understanding, let's move on to the next slide. The next thing we need to know is some properties. Let's do something before we move on. Okay. Sometimes in questions, you could also be asked to find. So, for example, I can ask you to find what the cumulative distribution. So, for example, x, okay, is less than or equal to what? 3. Okay. So then the probability of x being less than or equal to 3 is going to be what? The probability of x equal to 3. Okay, x equal to 3 plus the probability of x equal to 2. This should all be capital X, okay? Capital X equals to 2 plus the probability of the random variable assuming the value, what, 1, okay? So we are saying that the probability that the random process has a value less than or equal to what, 3. Yeah, and this is going to be the probability that x equals to 3 is 3 over 6, okay, plus the probability that x equals to 2 is what? Is 2 over 6. Then plus the probability that x equals to 1 is what? 1 over 6. So this in all will give us what? 6 over 6, which is equal to what? Which is equal to 1. Okay? So at other times, x could be in between two values. So I could write x is what? Less than or equal to what? Is greater than or equal to 1. Okay, but less than what? But less than 4. Okay? You could also be asked this question. So you just take note of how to find the CDF, okay? The cumulative distributions for the probability function. Okay, so next we're looking at the properties of the probability distribution. The first property of the PMF, that's probability mass function, is the mean, okay? So you take note of the formula. The mean, which is also the expectation of the process, is defined as what? Summation of xi times its corresponding what? Probability, okay? So what we are saying here is if we sum up all of the product of x, the outcomes with their probability, then we are going to get what? Then we're going to get the expected value or the mean of the process, okay? And the variance is also going to be the expectation of x squared minus expectation of what? X, okay? Technically, this is just the expectation of what? The expectation of x, the process, minus what? Mu squared, okay? We know this. We know this from the previous class, okay? Oh, yeah. The variance is just what? The expectation of the square deviates, okay? Or of the square deviates. So that gives us the expectation of x squared minus the expectation of what? X squared. Okay. So in finding the variance of the process, okay, look at it carefully, right? Expectation of x squared is going to be like this. It's just like finding the expectation of x, but this time you have to square the x and multiply by their probabilities, okay? But for this component, it is the same expectation of x, okay? This should look like this, expectation of x all square, okay? Good. So the expectation of x is what we have up here, which is summation of xi times p of xi. So in other words, when you're finding the variance, all you need to find is this quantity, the first term here, okay? Because you would have found this, which is already the expectation of x. You would have found it for the mean. So you don't need to find the second quantity here. You only find this quantity, okay? And then come and subtract a square of the mean you found earlier from it to get the variance. Okay, so take note of the formula. Take note of the formula if you don't have it. Okay, take note of the formula. Okay. Yeah, can I continue?
Yes, please.
Okay.
Yes, sir.
Fair.
Yes, sir.
So I think that is it. Yeah. So we have an example here on the expectation. Okay, we'll look at that, and after that, we'll wrap up. I think we have just like 4 minutes to go. Now, we return to this example which we solved earlier. If we are to find expectation, okay, like we said, the expectation of the process, okay, just summation of x times p of xi. Okay, good. So summation from I equals to n, I equals to 1, sorry, to n. Okay, good. So this is x, this is p. It means you have to find the quantity xi times p of x, okay, which will be 1 times 1 over 6. That gives us 1 over 6. 2 times 2 over 6, which will give you 4 over 6. 3 times 3 over 6, which will give you 9 over 6. And then 4 times 0, which will give you what? 0. Okay. Then all you do is to sum it. So you add this plus this plus that. And when you sum, you should get 2.33, okay, as your expectation of the process. Okay. So all you do is to multiply the x with their corresponding probability. Then you sum everything up, and that will give you the expectation of the process. Okay. So in summary today, we've looked at the concept of probability. We said that the reason why we're even looking at probability is because every experiment has an outcome, and this outcome occur with what? Chances. Okay. And hence, to explain or to describe or to predict these chances of occurrence, we need to understand the concept of probability. And we said that the set of all possible outcomes of the experiment is a sample space, and then a subset of event of this sample space is an event. And the probability of an event is also defined as what? The number of outcomes in the event over number of outcomes in the sample space. Then we look at joint event, we look at the addition rule, okay, where we talk about mutually exclusive events. And we said that under mutual exclusivity, then the probability of A or B will be the probability of A plus the probability of B. And then we also look at independent or multiplication rule. And we said under independence, then the probability of A and B is equal to the probability of A times what? The probability of B, okay? And we said that was derived from the conditional probability, which we also saw that the probability of A given B is just the probability of A and B over the probability of B, okay? Very good. Which we eventually derived the independence rule, solved some questions on that. And then we came to probability distribution. We talked about the random variable as a function or a rule, which assigns elements in the sample space to real number values. And then we also look at the probability distribution as the list of the possible values of the random process with their corresponding probabilities. Then we came down to look at some properties of the PMF, okay, which is the probability distribution for a discrete random variable, Okay, we looked at how to find a probability distribution, and also we wrapped up on the properties of the probability distribution. Okay, so on that note, we'll wrap up today's class. Please take note, the lecture starts from 5:10 and ends at 7:10. Okay, I have another class immediately after your class, so don't delay in coming to class. Okay, very good. We're already far behind time, so I think we'll wrap up for today. Then if there are any other discussions, let's talk on the WhatsApp platform. Okay, yeah.
Okay, sir.
On that note,
Yes,
I bring
sir.
today's class to a close. See you all next week.
Thank you, sir.
Thank you, sir.
Okay.
All right, sir. Thank you, sir.